Hello everybody, this is Naveen S. Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So today we will continue the topic Fourier transform. So few problems we solved in our previous class. So today we will continue the same. So find the Fourier transform of the function f of x is equal to 1 minus mod of x for mod x less than or equal to 1, and it is 0 for mod x greater than 1, and hence deduce that integral 0 to infinity sin square t by t square with respect to t is equal to pi by 2. Okay, so it's a continuation of the Fourier transform. So the function f of x is given and it is defined as 1 minus mod of x for mod x less than or equal to 1, and function is defined as 0 for mod x is greater than 1, and hence deduce the integral sin square t by t square between the limits 0 to infinity. And yesterday I explained, in the last class I explained that mod x less than or equal to 1 implies that x lies between -1 and +1. And since for mod x greater than 1 the function is defined as 0, therefore the limit of this function lies between -1 and +1. And since we are finding the Fourier transform, so we have a solution here. We have a Fourier transform of f of x, and it is denoted as f of u is equal to integral minus infinity to plus infinity f of x into e raised to iux with respect to x. Okay, so this is representing a Fourier transform of the function f of x. Now just we need to replace this f of x by the given function, and since the function f of x is defined between the limit mod x less than or equal to 1, mod x less than or equal to 1, nothing but x value is lying between -1 and +1, and it is defined as 1 minus of mod x. So replacing here, so the limit is between -1 and +1, and f of x is nothing but 1 minus of mod x into e raised to iu x with respect to x. And since here in this function we are having a mod of x, and we know that mod x will be always equal to plus x for the positive range, and mod x will be always minus x for negative range. And since we know that here this limit -1 to +1 contains both negative range as well as positive range, so that's why we are going to split this integral as positive range as well as the negative range, so that we can simplify this mod function. So I will split this integral as -1 to 0. So -1 to 0 means definitely it is a negative range. In the negative range, mod x will be always minus x. So minus into minus become, it is 1 plus x into e raised to iux with respect to x, plus the next limit will be 0 to 1, that is representing a positive range, and in the positive range mod x will be always plus x. So it is remains 1 minus x into e raised to iux with respect to x here. So now we need to evaluate both the integrals separately. So and since it's a product of two functions here, 1 plus x into e raised to iux and 1 minus x into e raised to iux. Obviously it's a product of two functions. Out of that product, one function is vanishing function. Vanishing function means as you differentiate it, it will become 0 after few derivatives. Therefore 1 plus x and 1 minus x both are vanishing functions. So to integrate it, to evaluate this integral, definitely we are going to use the Bernoulli's rule. What is Bernoulli's rule? Bernoulli's rule is nothing but integral of u into v. It is used whenever we are integrating the product of two functions. Out of that product, one function must be vanishing. So integral of u into v is nothing but u into v1 minus of u dash into v2 plus u double dash into v3 minus u triple dash into v4 and so on. So here I will take this 1 plus x as u and e raised to iux as v. So therefore the first integral I am evaluating now. So it is 1 plus x as it is, that is u as it is. Integral of v means integration of e raised to iux is e raised to iux divided by iu. Minus, according to the formula there is a minus sign, and the derivative of 1 plus x will be 1 into, again integration of this term e raised to iux divided by iu will be e raised to iux divided by I square u square. So complete, because the derivative of 1 becomes 0, so we stop here only and we apply the limit minus 1 to 0. So this is the first integral. In a similar way, the second integral, again u into v here. So 1 minus x as it is, that is u, integration of v, that is v1, integration of e raised to iux is e raised to iux divided by iu, minus derivative of 1 minus x will be minus 1, and integration of e raised to iux by iu will be e raised to iux divided by I square u square, and complete the bracket and apply the limit 0 to 1 here. Now simplifying, applying the limits here for this terms. So upper limit is 0. So first applying the upper limit. So 1 plus 0 will be 1 here, into e raised to 0 will be 1, remaining is 1 by iu. And here again applying the upper limit 0, so it become e raised to 0 will be 1. And since we know that I square is minus 1, okay, the value of I square is minus 1, so minus into minus become plus, and that become 1 divided by u square. Now applying the lower limit, but while applying the lower limit, definitely we are going to take minus for every, we will multiply every term by minus. So 1 minus 1 will be 0, 0 into anything will be 0 here. And since here we are having I square, and I square is nothing but minus 1, minus into minus become plus here. And since we are applying the lower limit, therefore we are going to have one more minus, so that is minus of e raised to minus iu, okay. So obviously because we are putting x equal to minus 1, so it is e raised to minus iu divided by u square. Why this minus? Because I square is nothing but minus, minus into minus become plus, and since we are applying the lower limit, therefore it is minus. So the first limits we applied. Now coming to the second term, plus here applying the upper limit 1. So 1 minus 1 will be 0, 0 into anything is 0. And coming to the second term here, so minus into minus become plus, and since we are having I square is nothing but minus 1. So minus 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 become minus only. So here this plus will not come, so it will be minus. Applying the upper limit, so it become e raised to iu divided by u square, okay. So minus into I square is minus, so this minus, so we have this term. Now coming to the lower limit, and since while applying the lower limit we know that we need to take a minus sign for every term, we need to multiply the terms by minus sign. So 1 minus 0 will be 1 and e raised to 0 will be 1, and since we need to multiply this term by minus, so it become minus of e raised to 0 will be 1, so 1 divided by iu. And here minus into minus, again I square is minus, so 1 minus 2 minus 3 minus, and since we are applying the lower limit, therefore we are going to have one more minus, so multiplication of 4 minuses will give you plus sign, and e raised to 0 will be 1 by u square. So this is the step after applying the limits here. Now simplifying further, so here 1 by u square plus 1 by u square will be 2 by u square, and this 1 by iu minus 1 by iu get cancelled, and this third term and this last term common is obviously 1 by u square, that is plus 1 by u square. Inside the bracket it will be obviously so 1 by u square, 1 by u square is 2 by u square, and here these two terms, obviously the third and fourth term, sorry, it is third and fourth term will be here minus sign will come, because here both the term having a minus sign, so there is a minus sign, so 1 by u square, and here it will be e raised to iu plus e raised to minus iu, because we have taken minus 1 by u square as common. So the next step will be 2 by u square as it is minus of 1 by u square into bracket, and since we know that e raised to I theta is nothing but cos theta plus I sin theta, and e raised to minus I theta is nothing but cos theta minus I sin theta, and therefore e raised to I theta plus e raised to minus I theta will give you 2 times of cos theta. So therefore e raised to iu plus e raised to minus iu will be 2 times of cos of u here. Okay, using the definition of e raised to I theta and e raised to minus I theta, when you add it you will get 2 cos u. So simplifying here, so obviously in both the term now we are having 2 by u square common, so inside the bracket it will be 1 minus of cos u. So 2 by u square common in both the term, and we are having 1 minus cos u, and since we know that 1 by it is 1 minus cos u is nothing but 2 times of sin square u by 2. So therefore we have here I will write it is 4 divided by u square into sin square of u by 2. And just for our convenient I will write one more step here, that is sin square u by 2 divided by this step. I will write it in one more form, that is I will take this 4 in the denominator. So when I take that 4 in the denominator I will get here u by 2 the whole square. So this is the Fourier transform of the given function f of x. And one more thing you need to observe every time is that when they ask you to find out the Fourier transform, then assure that the answer of the first part must resembles to the integral which we are evaluating in the second part. And since in the answer definitely this sin square u by 2 divided by u by 2 the whole square is resembling this integral. So in the next half part we need to evaluate this integral. Since from the first part we obtained the Fourier transform of this function f of x, and it is sin square u by 2 divided by u by 2 the whole square. So this is the Fourier transform of the given function f of x, which we obtained it from the first part. Now in the second part, we need to evaluate this integral. Obviously, in the second part, there is no much evaluating the integral. Instead, we just try to simplify this function by substituting in the inverse Fourier transform formula. And every time you remember that while deducing the second part, we are going to use the respective inverse formulas. So we have an inverse formula here, the inverse Fourier transform formula. F of x is equal to 1 divided by 2 pi integral between minus infinity to plus infinity f of u into e raised to minus iux with respect to u. So this is the inverse Fourier transform formula, and every time remember, whenever we are finding the deducing integral, in that case we are going to use the inverse Fourier transform formula. And since already we are having f of u from the first half, so we substitute that f of u in this, and we try to get the value of the integral 0 to infinity sine square t by t square with respect to t as pi by 2. So we need to get the answer pi by 2. So now substituting f of u here, so it is 1 by 2 pi minus infinity to plus infinity. F of u is nothing but it is sine square u by 2 divided by u by 2 the whole square into e raised to minus iux with respect to u. And this is the f of x, the given the function we need to find here. Now when you observe this integral, in this integral there is an absence of this exponential function. There is no exponential function which integral we are evaluating. Therefore we need to eliminate this exponential function by substituting the value for x. Therefore to eliminate this exponential function, we are going to substitute the value x equal to 0, so that when we put x equal to 0 here, it become 1, and obviously remaining is only this sine function. So put x equal to 0 and the function f of x become f of 0 is equal to, it is 1 by 2 pi integral minus infinity to plus infinity sine square u by 2 divided by u by 2 the whole square with respect to u, because we have substituted x equal to 0, so this e raised to 0 become 1. Simplifying further, and since we need to have the value of f of 0, and since we know that 0 lies between minus 1 and plus 1, and since mod x is less than or equal to 1 implies that x value is lying between minus 1 and plus 1 here. Therefore x equal to 0 lies in this range. Therefore we need to put that x equal to 0 in this function, so 1 minus 0 will be 1 here. Therefore we have f of 0 as 1. So 1 equal to, it is 1 upon 2 pi integral minus infinity to plus infinity sine square u by 2 divided by u by 2 the whole square with respect to u. Now we need to reduce this integral into this form. Therefore I am going to take a substitution u by 2 is equal to t, and differentiating with respect to t here, we have du by 2 is equal to dt, that is nothing but du is equal to 2 times of dt. And since the limits will remain same, so obviously the limits will remain same as minus infinity to plus infinity only. So I cross multiply this 2 pi here, so I get 2 pi is equal to integral minus infinity to plus infinity only. Then replacing u by 2 as t. So we have sine square t divided by t square, and this du is nothing but 2 times of dt. So simplifying further, it is 2 pi, taking this 2 outside, so it is 2 outside, integral minus infinity to plus infinity, and here it is sine square t by t square with respect to t. And since this two get cancelled, and we have here pi equal to integral minus infinity to plus infinity sine square t by t square with respect to t here. And since sine square t by t square is a even function, if sine square t by t square is a even function, then by the properties of integral, we have the properties of integral, that is minus a to plus a f of x dx can be written as 2 times of 0 to a f of x dx if f of x is a even function. So minus a to plus a f of x dx can be written as 2 times of 0 to a f of x dx if f of x is a even function. And since here sine square t by t square is a even function, therefore we can write this as pi is equal to 2 times of 0 to infinity sine square t by t square with respect to t. Therefore taking this to this side, and we have pi by 2 is equal to the same integral 0 to infinity, it is sine square t by t square with respect to t, and hence the value of the integral 0 to infinity sine square t by t square is pi by 2, which is required answer, and hence the proof.